Good afternoon. It is with great pleasure that I present our work at Mobi Health. Today I will present a work entitled Measures to Improve Health Performing of an Accommodation Building, a study case. Here is the summary of what will be presented. First, I will do an introduction about the theme, then I will talk about some traditional natural ventilation solutions, and then I will present the study case, the problem, the solution, and some remote control options that were made. In the end, I will draw on some conclusions and talk about future works. Traditional dwellings can be rehabilitated for tourism accommodation purposes. Several technical aspects, such as providing health and comfort conditions, are still more critical in this context. Technical aspects are views, natural light, space, ventilation, thermal behavior, acoustic, humidity, and smell. Considering that this type of dwelling are likely to be placed in the city centers, these concerns tend to increase. The main goal of this research is to emphasize a natural ventilation system proposed in the rehabilitation process of a traditional Portuguese dwelling, and to present the automatic control system used to manage the temperature, ventilation, and light. The authors also intend to alert to the importance of using and the development of new systems of control and prediction that can detect hazards, like the presence of dangerous gases, that can bring health problems. In terms of ventilation, it can be natural or forced. Natural can be considered more sustainable. In contrast, a forced ventilation system may be more high-tech, requiring mechanical devices and energy consumption. But forced ventilation may be the only solution considering the specificities of the traditional buildings. For instance, the existence of underground floors, the lack of windows or doors, the density of the construction, the morphology of the landscape, and the insulation can contribute to the requirements of a ventilation system. A proper ventilation system allows good air quality in a building and contributes to the accommodation comfort. It avoids inconvenient smells and health-related problems such as allergies and breathing difficulties. At the same time, a proper ventilation system may avoid incidental scenarios, such as the high carbon monoxide levels that can cause death. Systems like control and prediction are needed to detect other hazards like radon or gases that can be dangerous to health. The comfort level of the accommodation is also a concern, and having some control over temperature, humidity, smell, and noise can also help. Among traditional Portuguese dwellings, several building technical aspects guarantee natural ventilation. For instance, conventional timber frame windows and doors usually have poor insulation. The typical kitchen chimneys allow air circulation from inner and exterior spaces. Fireplaces may achieve the same feature. Meanwhile, the typical timber pavements and roofs are poorly isolated, allowing natural ventilation through different rooms. Thus, traditional dwelling may guarantee natural ventilation, even if inefficient. On the other hand, new construction may behave differently, considering that they are much more isolated. Pavements tend to be reinforced and made of concrete. Windows and doors are sealed, and walls and roofs are insulated. Therefore, there is a need to build a proper ventilation system using pipe networks and grills. Level differentiation of entrance and exit of air is recommended. Bathrooms, closets, and storerooms may require this type of system because they tend to be unprovided of windows. When this type of natural ventilation is inefficient, thus it may be reinforced by forced ventilation, which really relies on a mechanic extractor. For the study case, a traditional Portuguese dwelling was used. Um, the, the dwelling is a two-floor building located in Lamego city center. in the historical part of this city near the castle. Lamego is located in the Douro Valley, rich in Baroque architecture and religious buildings. It is an international tourism attraction. As a typical dwelling of the north part of Portugal, it is built with exterior granite masonry and tabique walls. The pavements and roof were built with timber. Windows and doors were made with timber frames, and the cover of the roof was made of ceramic tiles. On the other hand, the building presented a lousy level of conservation, in which the main structural elements were almost destroyed. There was no point in rehabilitating or reinforcing most of the building, so only the external walls were maintained. Municipality regulations only allow the use of timber or steel or structural building materials for this type of rehabilitation process in this area. Therefore, steel frames, glulam pavements, and roofs were used. This building was rehabilitated to be converted into a three-floor flat tourism accommodation. This specific building is lacking in terms of space. It is placed between two other traditional buildings and shares the same lateral walls. Therefore, only two exterior walls are allowed to have windows. Thus, natural light and natural ventilation can be potentiated by these two walls and through the roof, where it is possible to place windows and grills. At the same time, approximately one and a half of the building is under the level road. These building aspects created several difficulties concerning the air ventilation of the house and lighting. Musty smell, humidity, stagnant air, and dark spaces resulted from these building constraints and resulting in an unhealthy living dwelling. Thus, the original building could not meet the actual requirements of living comfort with quality. Based on the above explanation, some building challenges existed during this rehabilitation process. One of the building solutions proposed to solve the above identified problems consisted on having an atrium on the left side of the building and next to the facade facing south. This atrium connects all the floors from the basement to the first floor. The roof of the atrium is made of double glass to allow natural light entrance. This roof has surrounding grills in connection with the structure of the atrium. This structure ensures air circulation from the inside to the exterior and vice versa. At each floor level, each flat has a door and a balcony connecting to the atrium. On these floors, the atrium has windows placed in the main facade of the building. It is relevant to add that each balcony is built with a steel grid pavement to allow air circulation and natural light passage between floors. At the basement pavement, a 200 millimeter diameter pipe network of PVC was considered to allow the air circulation between the interior of the atrium and the north face facade at this level. There is approximately a 9-meter height path to take into account. This air circulation path can have two directions throughout the year, depending on the temperature. Supposing the temperature at the top of the atrium is higher than the bottom, which is likely to occur during the warm temperature period of the year, in this case, the air tends to circulate from the bottom to the top of the atrium. On the other hand, the air will likely circulate from top to bottom. This last scenario may occur during autumn and winter. And in addition, if the temperature reaches a high value at the top of the atrium, it can generate conditions that stop the natural circulation of the air. This problem may emerge in this case, particularly an unacceptable musty smell. It was noticed. And this problem affects all three floors. So the proposed natural air ventilation system had to be reinforced with a forced air ventilation system. Another pipe network and an electrical extractor are the components of this additional forced air ventilation system. It was also placed on the pavement of the basement floor and nearby the back window of this floor. In this rehabilitation process, other technical aspects were also a concern, which required additional care. It is not an intelligent house, but it used technology to reduce energy costs, increase comfort, and facilitate management like tourism accommodation. To have a more efficient energy rehabilitated building, the air conditioning system of each flat is remote controlled. It is possible to switch on or off the air conditioning devices using an online platform. It is also possible to know the temperature of each flat remotely. The light system is also remote controlled as well as the ventilation. In this way, it is possible without going to the place to turn on the air conditioning before guests arrive to have a cozy atmosphere. It is also possible to turn off all or part of the electrical system, namely the sanitary hot water heating system when the guests leave the apartment. In addition, the blackout curtains are also remote controlled. With this technical solution, it was possible to obtain a more technological rehabilitating building and take a step toward an innovative construction and an intelligent building approach. Now we have conclusion. There has been an increased demand for tourism accommodation, and rehabilitating traditional dwellings can help solve this problem. However, the rehabilitation of traditional dwellings for accommodation purposes may present additional technical aspects to be considered. Health issues have to be avoided, and the good quality of the inner air is one of the aspects that is fundamental to guarantee. And a natural ventilation system may be a good option because it may be more environmentally friendly. When not enough, reinforcement with a forced ventilation system may be the required building option. Remote control options such as thermal control, ventilation control, and access to accommodations have shown interest because they are energetically more efficient, less time consuming, and more convenient. With this paper, the authors also intend to alert to the importance of using systems of control and prediction that can detect hazards that can bring health problems. In this work, a natural ventilation system solution is presented and described. It is also introduced the required reinforcement of this system. The proposed solution may be applied in future rehabilitation processes. As future works, we intend to undertake a campaign of measurements over time of variables like outside and indoor temperatures, humidity, and the presence of CO and CO2 gases. Another possibility is implementing a system of control and prediction that can provide quality health and comfort to the users. Here are the references used in the development of this work that can be consulted if necessary. I hope you enjoyed our presentation. Thank you very much for your attention.